Hello, welcome to a new tutorial presented by DSH How to be. In this tutorial, we are going to learn how to plot functions in part 2. In the initial tutorial, the functions plotted were lines, and lines are integral parts in mathematics. Now we'll start here by plotting quadratic functions. So quadratic functions. In this tutorial, we are going to learn quadratic functions. So we come back and write quadratic functions. Now, when you want to learn quadratic function, this initial codes were in order to place our curve in the normal format with the x and the y axis. So let's try to modify a little bit some positions. So we are going to set again the labels here. To do that, quadratic function, come up here, we set label 1 x at that position, and set label 2 that. So when you do that, we come back again on our curve. We are going to have, so let's try again to plot. So we try again to change now the position. Now the x and the y were on the same position. We change the arrow 2 now to this position. And place comma here and place 1.5 here. Come back. So we have changed all the position and placed our x and y as such. So on -1.5 and all this, so we have the direction of x and y well written on our graph. Now we now go and see quadratic functions. Come back to quadratic function again. If you want to label the title of your graph, you can write the word quadratic function. So I'll set title above. So I'll set title and I'll place quadratic function. So when I do this, you see that the word quadratic function is found here. So quadratic, let's arrange it is quadratic. So we have this. So this is quadratic function written above here. We can also decide to set the key outside. So I'll set key out, I'll place the word outside, so that my key is outside, and then I have the position of the key here so it should not interfere in my graph. Now the different quadratic function you can have, I will plot down quadratic function by using this same plotting with the different domains of x written. So now we are going to have, let's say my first quadratic function I want to write is x squared. In order for you to write squared now in this with the gnuplot, you need to write the double assay sign as such, and then you place squared. Descend, we are going to have this graph x squared. Now let's say you want to plot the graph 2x squared. So I'm going to place now here instead 2, and when I place 2 there, I need to place here a star. Now a need is shown that you need to space a space between the range and the function you want to plot for you to have not an error. If I go down, you see that you have this, but it's always necessary to place a space between the range and this. All that is going to produce now this other function, this quadratic function as such. Now let's say you want to plot now with this range 2x squared plus x plus 5. We are going to have this. Now let's say I instead want a maximum turning point. So in this case, I want that I'm going to place a negative here at this e here, and I'm going to space here. I'm going to have a maximum turning point as such. So these are all the graphs which can be plotted with quadratic functions with gnuplot. Now you can go now. The next graph you are going to plot are going to be polynomials. So plotting polynomials. So if you want to plot polynomials, you still have to use now plot and then know the plotting scheme. So you know that polynomials are having x which are repowered, x squared with power of 2 and more than 2. So if I want to plot, let's say x cubed, I'll write x raised to the power with double axis sign and then I write 3. So you are going to have this as your graph of polynomial. So let's say now I want to plot my graph x cubed plus 2x squared. So I'm going to write plus here and 2 times x asterisk squared as such. So you are going to have this graph. So if I want again to write x cubed plus 2x squared plus 5, I'm just going to come up and then I'm going to add plus, let's say even x plus 3. So this is the new graph that's going to be formed. So all these are graphs which are formed by the gnuplot. Now the next graph you can form are the sine functions. Sine functions are still easy. When you come to plot, now you need to know that with sine, the range that you need to place here, it's no more -10 to 10. So we are going to change the range now to the case of sine. You know that sine is starting from let's say -3.4, because when you place a range here, you need to consider that they are in radians. So it's going to be -3.14 and it's going to end at 3.14. So that's a new range. I'm going to close it. So when I have this new range, I can now plot my sine. When you want to plot sine, you need to know that the dummy that is going to be there, or the variable that you always need to use, is x. So I'll place into bracket x. So when I do this, you are going to have your sine curve within the range I've placed and in that domain. So this is the range I've placed in this domain. Now if you want to make the sine curve a little bit closer, you can now set I'll first set if I want to change the radian form to angle form, I will now set angle of sine in instead degree. So when I set in degree, I can now change this plot, this range here, to a range in degree. So I'll first start by setting the x range now from -360 degree to 360 degree. I'll close it. Now I'll also set the y range similarly to that. Then I'll plot now with a range which is between -360 degree and 360 degree as such. So -360 degree to 360 degree. So when I plot this, I have this curve. So the curve is not well seen because the range here is too far. So a point to note is that the curve is not well seen because of the y range. We know that the range of the sine curve is between -1 and 1, so I need to change this y range here. So I'm going to place here from -1 instead to 1 here. So when you do that, you come back again on your plot and you see that you have this. So the plot is well seen from -360 degree to 360 degrees. So this is how to plot sine curves. Now to plot cosine curves, we need to come here and you write cos instead of sine. So this is the cosine curve from -360 degree to 360 degree. To plot the tan curve, you need to come here and instead write tan. So tangent, you need to write tan here. So this is how the tangent are going to go with their limits going toward an asymptote. This is a tan curve. Again, to plot, let's say I want to plot the arc. If you want to plot the arc, it's always good to change now the range. You know, the arc cos and the arc sine have a range which are interchanged with x and y. This is now with the knowledge of mathematics. Now I first need to go now here and set another x and y range. So my x range in this case is going to be, so this is going to be the x range. So the x range in this case will be from -1 to 1. So this is the x range, and the y range will be from -360 360 degrees. So now I'm going to plot this in from negative that to that of arc sine. So let's say plot arc sine. So you have this is not well seen. Here we realize that the graph is not well seen because of the range of the x. So you need to change the plotting scheme here. So I'm going to say from -1 to 1. So let's change it from -1 to 1 and see what is going to be shown. So -1 to 1. So now you have your arc sine curve which is being shown. So from -1 to 1, this is your arc sine curve which is being shown here. This is why it's very important to write ranges. When you have to know the function and the range in which that function exists for you to plot a perfect function with gnuplot. So let's go now with the arc cos. If you want to draw arc cos, you write cos here and then you enter. This is going to be your function which is being drawn. So the x-axis has been unset and the y-axis, but that will not be great 0. So set range that. So let's continue again by plotting the arc tan. So we are going to plot tan here. So this the x-axis is very small here because we didn't change the range, because we said initially that it should be from -10 to that. So it's going to be as such. Now, in order for you to plot the sine h, the hyperbolic sine and the hyperbolic cos, now we are going to change again this x and y range. So we are going to set back our x and y range to be -10 and 10. So we set x range, come back up here. So the x range is that. We're going to set now the y range similarly to that. So this is the y range, and now we are going to have now the plotting domain. The plotting domain now will be from -10 to 10 as such. And now what is going to be inside is going to be the hyperbolic sine. To write hyperbolic sine function, you need to add sine h and you put in bracket x. So it's going to plot this. So this is the hyperbolic sine function which is being drawn. So now let's draw the hyperbolic cos. So to draw the hyperbolic cos, come back, you write cos h. So this is the hyperbolic cos function. These are the different hyperbolic functions that you're going to have. So you can hide the hyperbolic tan. So let's come and write tan h to see what you are going to have. So the tan h is going to give you insert this function. So these are the functions which are being drawn. All these are the functions which are being drawn with gnuplot, just by knowing the function name and knowing how to use the different commands. Now you've seen how to draw the different functions which are shown in gnuplot. Now the next thing again gnuplot that you need to know is how to use function. If you want to know other functions, you can come here. You have elementary here. These are different functions that can be used again. You can have square root. So let's say I want to plot now the function or exponent, or you want to plot logarithms. You can. These are different functions that are involved. So let's say I want to plot now in this same range. I want to plot the square root of x. So I'm just going to write square rt in bracket. I place x. So now the function square root of x is going to be shown as such. So if I want to write again the square root of x squared, so x squared plus 5. So I write x squared here plus 5. So this is square root of x squared plus 5, which is drawn here. So now let's say I want to plot again other complex functions as so this is square root. Let's say I want to plot again logarithm. So logarithm. So let's say I want to plot the ln of x squared. So if I want to plot the ln of x squared, you need to put in your mind that the ln in plotting in the gnuplot is not written as ln, but instead written as simply as log. So when you write log here, it's considered in gnuplot as ln. So when you write log, you continue again by writing the function you want to be entered in it. So I want to remove now this square here. I want to write let's say I want to write the log of x squared, or let's say x first. So the log of x is going to be plotted as such. Now let's say I want to plot now the log of x squared plus 5 plus 4 as such. So now the log of x squared plus 4 is going to be drawn as such. Now in order to draw the ln, that's the ln. Now in order to draw the log to the base 10, what you need to do is only to add 10 at this point here. Just write 10 here. So that's log to the base 10. So when the log to the base 10 is going to similar as ln of x, and it's going to be this. So you again have another one, the log to the base 10 of this, of that. I'm going to paste 10 here. So when you have this, you have this function. It's similar to the ln. Now we have finished the simple function. Now we can go to fractional functions. To plot fractional function, let's say I want to plot x squared, or I want to plot x plus 1 all over x. So I want to plot in bracket x plus 1 divided by, in bracket, x plus 2. So let's say I want to plot this function. So this function, if I want to plot it, I enter, you see that it is going to have an asymptote somewhere here. This asymptote is going to be shown as such. So in order to place against the asymptote, I need to place an arrow at this point and find the location of this point. So this point here you see here is an asymptote. So it's this x squared is going to draw as such, and then it's going to be drawn as such. So this is an asymptote here. Okay, after having this function, you can have, let's say I increase the power of the numerator by 1. So let's say I'm going to plot a new function, x squared plus 1. So I come here, so I write now here the squared. You need to know that you are going to place double asterisk sign as such plus 1 as such here. So when you press enter, this is now your new curve. So you can see down is going to be shown as such here, and see up is going to be shown as such. So this is your new curve. Go down, you can now come again and plot another one. Let's say I'm going to place now the denominator is going to be x squared. I'm going to cancel this, and then the numerator is going to be x. So I'm going to place here double asterisk sign r squared. So when I have this function. This is a function I'm going to have. So in order to visualize this function very well, I need to increase the domain of x, or the domain of y. So I need to come here with set y range, and I reduce it to negative. Let's say to negative. Let's say negative between between negative 4 and 4. So I'll increase the size. So between negative 3 is better 3, and I'll place here 3. So when I set it, you see that it has increased a little bit, so you can see the function much more better. So you see here that you have this here is going to be assigned as such here. So it's going to increase and then come here, it's going to go toward an asymptote. The asymptote here is going to be the x-axis. Going to come here and go to an asymptote. The asymptote here is going to be x-axis, but it's going to traverse asymptote at this point. So these are the two different ways to plot our graph using gnuplot. So from here you will see that we finish with plotting functions with gnuplot. So we've seen how to plot different functions, and the first thing when you want to plot functions is to set your arrows which are going to represent the x and y axis. After setting arrow, you need to set the x and the y domain for the corresponding function you want to plot. In this case, when you want to plot simple quadratic function, you can set for with different domain, which can set with ranges which are not really important. But when you are moving to complex function as sine, cosine, you need to place their domain where the x domain must be in degree. If you want to assign in degree, you need to set angle degree, and then you plot negative 360 degree, 360 degree for the sine. And you need to know that the y range must be between -1 and 1, else the graph is going to be excessively small. So you're going to place between this range, and you continue again. That's the cosine, the sine h. You need to know their domain and the ranges in which they exist. So from here we say thanks for your kind attention, and please don't forget to like and subscribe for Science Video Maker. Thank you.